All right, so now this is called a truth table. No surprise, because that's in the title. And so let's see how to handle a truth table. So the way you start is say, okay, well, there's a statement P and a statement Q in there because they told us that. Okay. And so you have to start with all possible combinations of true and false for P and Q. Okay. So the typical way I do is I just go true, true, false, false for P, and then true, false for Q. And you're going to get used to it really fast. Okay. Now, this is the and symbol. And so when you have something and something else, it is always false unless both of them are true. So, well, wait, that was not it. Okay, so they're both true there, but for the rest of them, one of them's false, and one of these two is false, and one of these two, well, at least one of them is false. And so that would be that. Okay. You can think of it like this. Here's the way I always think. It's kind of silly, but I always think, all right, P stands for plow the north 40 acres. And Q stands for weed the garden. Okay, and so we can say, all right, your mom says, hey, you can go out and play if you, but first you have to plow the north 40, and this means and weed the garden. So when is it true that you get to go out and play? Well, because we said and, it's only true you get to go out and play if it's true that you plow the north 40 and weed the garden. You got to do both. If you don't do both, if either one of them, if you missed one or both of them, then it's false that you get to go out and play. That's how I remember it. Or you can just say with an and, it's always false unless they're both true. All right. So then this one isn't so bad. It just says not P. So just do the opposite of your P's. So P is true, true, false, false. So we're going to go false, false, true, true. And that's it. Okay, so let's try another one. Okay, the first one is easy. It's what we just did a few seconds ago. It'll be false, false, true, true. Okay, now this time in this last column, we've got or. We've got this or symbol here. So this time your mom says, plow the north 40 or weed the garden, and then you can go out and play. Well, because she said or, that doesn't mean you have to do both. This means you got to do at least one of them. Or in other words, at least one of them needs to be true. So in other words, or is always true unless they're both false. So true, 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 false. Kind of the opposite of and. So or is always true unless they're both false. And remember, the and is always false unless they're both true. And that's just kind of how it goes. All right, so now we take it just a little bit further, and we'll say, now we got these parentheses. Okay, and it says you can add in some columns here if you want. You don't have to, you could, but I find it easier, although you could just do it on a paper, but I'm going to do it here. Otherwise you can't see it. Plus it's kind of cool to do it on the computer. I don't know why. So before we can jump straight to this thing, we've got to know what not Q and P are so that we can negate it. But before we can do that, we got to know what not Q is. So let's go here and we'll say not Q. Okay, so the opposite of Q. So that's going to be false, true, false. I wonder if it'll let you. Okay, true. Well, just curious. All right. Okay, so we've got not Q. So now it's time to figure out not Q and P, because we've got a not Q column and we have a P column. All right, so let's add in another one here. So we'll do, oh, darn it. Okay, I got to click over here. Okay, so not Q and P. Okay. So we're just going to look at this column, the not Q column, and this column, the P column. And we're going to combine them with and. And remember, and is always false unless they're both true. So in the first one, we've got a true and a false. so false. Next one, a true and a true. So we've got a true. Whoops, that's not a true. And then we've got a false and a false, so false. And then false and true, so false. Then it says, all right, now let's just negate what we just did. Okay, so do the opposites. So true, false, true, true. So the statement not Q and P, whatever it stands for, is always true unless P is true and Q is false. That's the only scenario in which the final statement is false. Okay, I'm definitely going to have these on the test. Okay, so on this one, kind of the same thing, but this time they give us a bar graph to give us a little information. So they define statement, statement P right here. The travel agency had the lowest sales in summer. It doesn't matter if that's true or false. That's just a statement. Okay. And the travel agency had lower sales in winter than in fall. That's another statement. And they say, all right, using P's and Q's, I feel like it's Monsters Inc. Using mostly spoons, we'll dig a tunnel. The travel agency had the lowest sales in summer, or the travel agency had lower sales in winter than in fall. Okay, so the first part, travel agency had the lowest sales in summer. That's exactly what this says. Okay, so it's not the opposite, so we don't need to use the not symbol. So we'll just say P. Oh, okay, I was just wondering if it could do that. Okay, then it says or. Okay, so we'll do our or symbol. Then it says the travel agency had lower sales in winter than in fall, which is exactly what this says. So we just do Q. Okay, we don't need to do not Q or anything. All right, so we've got our statement. Okay, so now in part B, we're going to find out is this a true statement right here? Okay. Well, first off, statement P. P is the travel agency had the lowest sales in summer. Is that true? No. In fact, spring had the lowest sales. Summer had the most. Okay, so statement P is false. Okay, then we need statement Q. Q is the travel agency had lower sales in winter than in fall. Is winter lower than fall? Yeah, that's true. Okay, cool. So now we can say, all right, P or Q, well, based on these two truth values. So or is always true unless they're both false. Well, they're not both false. So the result is true, and therefore we have just established logically that the statement, the travel agency had the lowest sales in summer, or the travel agency had lower sales in winter than in fall, that compound statement is a true statement. So that is how it's done. Okay. Okay, so on this one, we're using what's called De Morgan's laws. And let's see what that is just real quick here. So De Morgan's law says that if you have the negation of a conjunction in a parentheses like that, that's going to be the same thing as negating each one of them separately, but then changing the conjunction symbol in the middle, that conjunction to a disjunction or vice versa. So that would be, that's one version. Now the other version is like this. So you can see the two statements are pretty much the same. All you do is just take whichever statement or whichever symbol you have there and flip it to the other one. Okay. Now, of course, you can read it that way, starting with parentheses, or you can read it that way. You can use it that way, ending with parentheses. Okay, but that's De Morgan's law. So let's see what we've got here. Better change colors. Okay, so walnuts don't grow on lily pads, or caterpillars don't turn into butterflies. All right, so it looks like, um, let's see. So looks like we're saying not walnuts. I really should write this out the long way to make sure. Okay, so I'm going to say, okay, so W is a statement. Walnuts grow on lily pads. Okay. And C is going to be caterpillars turn into butterflies. Okay. All right, so you'll notice I left out the negations, the don'ts, okay, because I'm going to include them right now. I'm going to say, all right, so not, you know what? I don't think I can write it very well with the text editor, so I'm just going to write it this way. All right, so so it says not statement W, walnuts don't grow on lily pads, or not statement C, caterpillars don't turn into butterflies. Okay, so that's what we start with. That's the original statement. Now, if we're going to use De Morgan's laws, like we saw down below, whatever conjunction or whatever compound symbol you have there, you're going to end up with the other. We started with an or, so our answer had better have an and in it. Okay, which makes it easier to narrow it down. That's one reason I mentioned that. So notice the middle two, there's an or and there's an or. So it can't be the middle two because it has to have an and. All right. So what's it going to be? Well, like we saw with De Morgan's laws, we're going to write it with parentheses. And then we'll change that symbol in the middle, and then the negation sign goes on the outside. Okay, this isn't just a math thing. This is literally how logic works when you're making decisions. Okay, you don't think about this. I don't either, but usually. But this is how true logic actually works. Thank you, Mr. Spock. Okay, so we're looking for something like that, something that involves parentheses and the word and. Okay, and that negation out in front. So the last statement, walnuts grow on lily pads, that's W, and caterpillars turn to butterflies. So that's just this right here, but without the negation symbol. That's not what we want. The first sentence, it has those quote marks which suggest parentheses, so that's a good sign. It has the and it says it is not the case that, so not the case that, and then all this stuff inside the parentheses. Walnuts do grow on lily pads and caterpillars do turn into butterflies. Okay. Now, we're not determining whether or not this statement is true or false. We're just converting it. Okay. So you would pick option 1. Okay. And that's basically how De Morgan's law works. Okay. And now we are back to this stuff here. Okay, so complete back to truth tables. I like truth tables. So complete the row of each truth table, use T for true, F for false. All right, so this time there's 3 different variables. All right, whatever, that's fine. And they already give us the truth values for them. They could have said, hey, let's look at all possible combinations, but they didn't. So that's nice. So it says C or B. Remember, or is always true unless they're both false. Well, with C is false, B is false. So I think it's safe to say they're both false, or the whole thing is false. Then it says, let's do A, the first column, and the C or B column. So the 4th column. So now I'm only looking at A and C or B. And they're connected with an and, which is always false unless they're both true. Well, one's true and the other one's false, so it's false. Okay. Over here, let's do this. So it says, let's do the opposite of R. So that'll be false because R is true. Then let's do R and P. So R is true, P is false, and okay, so it's going to be false. Then we need to do Q and not R. So Q is true, not R is false. So and says they got to both be true if it's going to be true, and they're not, so it's false. Okay, now the last one, R and P. Okay, here's the R and P. R and P is false, we know that. Q and not R. Q and not R is also false. We want to connect them with an OR. Well, OR is always true unless they're both false, which they are this time, so it's false. And that's how it works, okay? It gets real repetitive, but yeah, you definitely practice these and get good at them, okay?